100% honest, when I first saw this thing, I had no clue what was going on. Hello everyone, Chris here, and today we're going to look at a very unique extruder hot end combo from MicroSwiss, the MicroSwiss NG. And from the first time I saw a picture of this, I was very interested to see how it was going to work. They've made some clever design choices, like locating the stepper motor to the top left of the carriage, and it drives the extruder from the side. So I don't want to spend a whole lot of time talking about it. It's just going to be easier for me to show you what's going on. This is a direct drive setup. You get the all metal hot end. It should expand your filament library. We'll go all over that, but let's just check out what's in the box. And here's a look at what comes in the box. You do get a stylish MicroSwiss sticker. You've got some hardware to install it on the Ender 3 style, CR10 style. This is going to be for your wheels. They give you a new eccentric nut, it looks like. Grub screws, collet clips, a collet. Some tools, some self-threading screws. You get the MicroSwiss all-metal hot end setup. That is the brake and the block. If you're familiar with MicroSwiss hot ends, the all-metal one, these should be good up to about 300C. You get your cable to convert your existing Ender 3 over to this motor. And then the whole extruder by itself. You do get a card. This will take you to the install instructions. And here it is. So let's just take a look at this guy. You do get a 3D printed shroud. It's going to mate up with your stock Ender 3 CR10 style fans, your 40mm here, and then that slim part cooling fan over here. Just that in itself, it's going to better direct the air where it needs to go for part cooling, so that's a plus. But let's take this shroud off so we can get a good look at the mechanism. So that just comes off with 2 screws, but here's what we have. So we've got a 1.8 degree LDO NEMA 17 here, a pancake stepper. It's driving a beveled gear here on its side, and it ultimately turns those extruder gears. And then you have your idler here on this arm. And if I take that idler arm off, you can see the drive gear down in here. It's a pretty unique solution, but this is going to give you an extremely short filament path. They say it's currently the industry's shortest, but it will be great for flexibles. Now they've done something pretty interesting with this part down in here, the part that actually feeds the brake. You can take a look in there a little tighter. They call this Twin Clad XT. I'm not exactly sure what that means, but hopefully that means it's going to be a nice clean filament path to get down to your all-metal hot end. No jams. Again, it's going to be great for things that aren't very rigid. It'll keep them from stepping out of that path. It's a very unique and seems to be a very clean direct drive setup. And this version, again, is for CR10 and Ender 3 styles. It comes with a specific plate to fit that printer, but this is going to be easy to mount on a lot of different styles going forward. While putting it back together, I also thought this was pretty unique. How they actually tension this arm. It's a very finely threaded brass piece. It just has a spring loaded in here, and when you screw it down, it tensions up against the housing there. It gives it a really nice fit. I like it. And the only other piece of assembly you'll have to do, you'll have to have that shroud off, is install the hot end, the brake, and the block. It does come with a nozzle, by the way. But you'll want to put this on and then tighten up that grub screw right here. And keep in mind the orientation, if you're using your stock heater or cartridge, which side those will go in. For the Ender 3, it's going to be facing the right side of the printer. From the front of the machine, of course. But we'll just snug this grub screw down. I highly recommend, after you've heated this up, leave your shroud off, come back in here, and tighten this grub screw up again, just to make sure the heat didn't move anything around. We'll also want to hot tighten that nozzle. So before we get to the upgrade portion of this video, let's talk about this extruder and this modification altogether. Now, this extruder is $120, but you have to take into account a lot of things. A lot of people like direct drive extruders. I prefer them myself rather than Bowden style, so that could be an upgrade for you. Also, this is a 3-to-1 drive, and the way they're doing it, it's going to have enough pushing force for anybody running 1.75mm filament. So you're covered there. They're all metal parts, they're very high quality, and you get the upgrade of the all metal hot end. So you can go up to 300C with this aluminum block. So any of those filaments you wanted to print before, like maybe polycarbonate, you should be able to now. So there's multiple upgrades here all in one package for that price. Also, you're not going to help your part cooling, probably, but it's definitely better than stock. You still have that same fan, but it should direct it a little bit better. And you're going to get away from that stock hot end, where you have that PTFE tube going all the way down to the nozzle that can cause a lot of problems. So this is going to fix a lot of issues. Is it going to help your print quality? Maybe, maybe not, but it will help your reliability. So now, let's jump in and see how we get this done. Now we can start taking things apart. Now keep in mind, when thinking about this install, what all this is going to replace. You're going to remove your extruder, the gears, the idler, all that, as well as the motor. So that's going to bring a little weight off of the printer. As well as you're going to be replacing this bracket, the complete hot end, you're going to direct drive, and you get an all metal hot end. So this is a couple of different upgrades all at once. And we all like stats, so take into account this assembly is 275 grams, and something very comparable to this, it's going to achieve the same kind of thing with flexible. The E3D Hemera, it's around 338 grams. So I'm just going to start by removing our Bowden tube. We can pull off our fan shroud. It's just these two screws here, this one and this one over here on the side. So this Ender 3 actually suffered from a heat break problem, so it's a great time to upgrade to this, but you don't need to remove all of this. Just pull these two screws, pull your hot end, and then you will need your heater and thermistor out of this block. You might have to heat up to get those to come out clean, but I am going to reuse the stock ones for this new setup. So we'll just take the hot end off. And this whole plate is actually going to get replaced, but we'll work on that here in a moment. We're going to reuse these fans, so we can remove our part fan. So just those 4 screws on the side, and then you've got 4 screws in here for your hot end fan. With the printer up to temp, I'm just going to go ahead and back out this nozzle. We can use that in another project. Most of the time you'd have to pull those 2 bottom screws that go into the bottom of that Creality style hot end to pull this apart. Again, mine suffered some trauma, so it did it for us. But we'll back out this grub for the heater. And then you have a Phillips head screw over here that retains your thermistor. With the hot end off, let's wait on this for a second until we go to the install. Let's go around to the back and we'll go ahead and pull that extruder and motor. You wouldn't have to, but you can save some weight, so why not? We can unplug that motor. We'll reuse this. There is a converter in the box. And we'll pull these 2 front screws here that hold the motor in place. One there, one back here. Then we can pull our arm with this screw back here. Be careful of that spring. Once that's off, there's a countersunk one right here to release that motor. Motor comes off, and we can set this aside. Now onto the bracket. Now the stock setup here, these screws go all the way through with nylock nuts to hold those wheels on. The micro Swiss version with this bracket, they thread into this part. And they do give you all the hardware to set this up, so you don't have to reuse this stuff. Just note it is a little bit different. So I'll pull these off. You can just take these off. You got an 8mm wrench for the back. And the only part you'll need to save is that wheel. And it really doesn't matter in what order you do this, but you will have to retension this belt. It's not under a lot of load, so pulling this isn't going to hurt anything. But I'm going to go ahead and loosen this up over here, because this is where I tension it. I'll show you when we put it back together. So that gives us some play in that belt to take that bracket off. We'll take this other wheel off. You can pull your belt. It just slides out of these slots right here. And then we'll pull that other wheel because we will reuse it. Again, they give us an eccentric nut to use on their version, so we don't need that either. So we've reclaimed our V-wheels. Now we're ready to go ahead and install our NG extruder. All this hardware is provided. They do put thread lock on some of these, so that's good to see. But we'll just put those top 2 wheels on, Bolt just goes through and it threads right into the back of our extruder plates. Make sure those are snug, but they're turning freely. No matter how tight you get them, it shouldn't impact how they turn. And then the bottom wheel, we can just put on really loose and then slide it on the printer. So screw through wheel, then your eccentric nut. I put the larger flange towards the part. Then it goes in your mount. Then from the front, washer and nylock nut. And with leaving it loose, it should just go ahead and set right on your gantry. And then we can tighten up our nylock nut. With this one, you don't want it super tight because you do still have to adjust that eccentric nut. And then with a 10mm wrench, you can adjust that eccentric nut to help it grip this rail. You don't want it too tight, but you want to make sure there's no slop in it. That nut's going to bring that bottom wheel closer to it, down in that V groove. When I adjust these, I like to back it out so there's just a little bit of slop and then gradually get it snug. Just small turns until I can't feel any more play sideways. Right there. Make sure it turns on the rail nice and smooth. So we're good there. We can go ahead and put the belts on. These crimped ends will slide back in those slots just like on the stock install. There are two different sets of slots on this side depending on length of belt. I'm going to go with the inner one. That's the one that fits better for this Ender 3. I'm sure that is so it'll fit multiple models. Belt's back on. You can go ahead and tension it up. I like to just put a screwdriver in over here up against the extrusion. You don't have to get these crazy tight, but you don't want them too loose either. And then tighten up these screws. Now we can go ahead and put in our heater and thermistor. The thermistor installs with that Phillips head screw just like the stock one does. It goes in a hole here on the side. And then the heater has two grub screws to sandwich it on that block. So you can just slide the heater in and hopefully that thermistor will line up right with it. So there's a look at the thermistor installed. Just put that screw in there. That thermistor goes down the hole below. That screw retains it. Just make sure you don't get it too tight. You might tear one of those thermistor wires. And then the heater cartridge is the same size as the block, so it goes all the way in, and then we'll tighten up these two screws. Now we can go ahead and put our fans on our shroud, but we're not quite ready to put the shroud back on yet. They give you some of these screws, the really aggressive threaded ones, that should self-tap to put those on in your plastic shroud. The larger, longer ones are for your hot end fan here in front. Make sure your hot end fan is blowing in the right direction. And then your part fan goes over here on the side with the 4 remaining smaller screws. And now our fans are on. So now I'm going to go ahead and heat up so that I can hot tighten the nozzle, snug up a few things, that grub screw before I put this back on. Now that we're up to temp, I do like to hot tighten a few things and check them, starting with the grub screws down here for the heater. We'll go ahead and tighten those up just a bit, make sure they're not loose. Also, go ahead and check that screw that holds your thermistor in. Make sure the heat didn't cause that to loosen up at all. And then on the micro Swiss, I like to tighten up this grub screw here that actually holds the brake in after it's been hot. It's usually not a problem, it doesn't work itself loose, but it's good to check it anyway. And then finally, grab a pair of pliers, and I want to hot tighten that nozzle. Now the stock nozzle in Ender 3 is actually a 6mm, the micro Swiss is the standard 7. I'm going to use my torque tool and just give it a click. So we should be good there. Now we can go ahead and install our fan shroud. Be careful with your wires here, you don't want them to block your idler arm. It shouldn't be a big issue, but it will slide in here. Also, the shroud that they have for this fan, it is really close to that heat block. So make sure you don't touch it and melt it when your nozzle is up to temp. Just be aware of that. One screw there, and one over there. Also note, Micro Swiss did make some parts and they put some mounting holes over here. If you have a BL Touch or a leveling sensor, there's a couple holes that you can mount it. The parts are out on Thingiverse, they're available on the Micro Swiss site. You can go ahead and put your sock on. Then we can run our motor cable. This is designed just to go to the stepper motor and plug into your existing motor cable. So you don't even have to open up the board. So we'll just plug it in here on the stepper side. And you can see our existing extruder motor cable. That'll just go right in there. And on a design like this, where they have you feeding the filament in direct drive, I still like to put a piece of PTFE here, just so the filament doesn't rub on any of the metal parts or that collet. And they give you a collet clip where you can stick it in there to keep it from coming out. Plus it gives the filament something else to pull on besides that extruder head. Also, that helps with wire management, which I'm going to take care of now. I can use this to zip tie some of these wires. It'll give them a little bit of movement, but keep them out of the way. So we've got our wires all bundled up. I just followed my hot end wires. This motor bracket actually makes a pretty good bracket to tie your wires down to. They're a little longer, but pretty easy to manage. So that's pretty much all there is to the hardware install. Now you have to take into account that this is a 3-to-1 drive, so your E-steps for your extruder are going to be much higher. The stock ones are usually around 93, I think mine's setting around 120, but you're going to want to start with a 400 for this one, so you will need a bit of a firmware change, but you don't have to flash the firmware. There's a couple different ways to do it, and I'm going to show you how to get that done. So let's do that now. Also, not all of these stepper drivers on the Ender 3 turn the same direction. I've seen them go one way or the other depending on the model that you have, so I want to make sure this is turning the correct way so we don't have to flip the cable over. So we'll get all that done. One thing I did want to mention before we go on to that configuration change is Microswiss has designed this where you don't lose any build volume. It's a little bigger than stock, but you can still get to all the locations on the bed, no loss at all. And that's not all that uncommon to see. When you see an upgrade like this, it might be a little bit bigger than the stock, so you lose just a little bit here and there, but not on this one. So I appreciate the thought on that design for this. Now, you could make this change from your screen on most printers. You can go in, if it's running Marlin, you can do configuration, advanced settings, and adjust your steps per millimeter. It's currently set to 120, that's what I dialed mine in at. Again, most stock is set to 93. You could just go ahead and crank this to 400 if you want. Depending on how your encoder is configured, that could take a while. I think it's just as easy to cable up and do it in the terminal. But that is an option if you want to do that. You would just then go ahead and store EEPROM after you made that change. In Marlin, you just go into configuration, store settings. It'll be there the next time you boot. I think it's just as easy to cable up and use something like Pronterface to do this. You can look at your current settings. You can look at everything with an M503. You can also just display them with an M92. And besides, if you want to do a PID tune, you'd want to come in here and do it this way anyway. But let's just make that update, M92 E400. That's what Microswiss recommends for this design. It's probably a great place to start, but remember, when you're setting this, you're always going to want to calibrate it, even if you're just changing to different types of filament. So we'll make that change. We can check it with that M92, make sure it's 400, and then we can save it to EEPROM with an M500. Now you should be good. The next thing I want to check is to make sure that motor is turning in the right direction, because not every Ender 3 board is going to be the same. I've seen it where you had to actually flip the cable over to get it going in the right direction. So let's heat up once again. I'm going to try to get you a view down in here so you can see the motors turn, but I'm just going to hit extrude for 100 millimeters. You see the gears start to turn. They look great. But that larger gear is turning clockwise, so the idler door is going to turn counterclockwise, so you know it's going in the right direction. So we should be good. So now we can go ahead and load some filament and start our testing. One thing I really do like about this design, the Hemera has it as well, is you do get an idler arm. So you don't have to go into the firmware to help you load the filament like you would on something like a BMG. So it's pretty easy to load. Just make sure you have a nice sharp point on your filament so it goes in easy. Remember, the filament path on these is very constrained, so it can be a little tricky, but this one's fairly straightforward. It goes right in, no problems. Just have to press on that door just a little bit. And you can adjust it right here. I do like the way they've done this. Their idler adjustment is just a fairly large brass knob with a spring loaded in it. And you will have to adjust this depending on the filament that you're using, especially when you go to something like a flexible. Another thing you're going to want to change up, because this is direct drive and how this extruder is configured, you're going to need very, very low amounts of retraction. Usually on an Ender 3, I run 5 millimeters. with 60 millimeters a second for the retraction. I did a couple of tests. I settled at a 0.8 millimeters of retraction at 35 millimeters a second. So much lower. It's going to save you a little print time as well. Here's a look at the retraction test. We could probably do a little bit more tuning. There's very few strings, but again, it's going to be a lot less than the stock Ender 3 Bowden setup. So here's some footage of it running. Most of the noise you're going to hear is just from the fans. It has very little backlash in that gear mesh, so you might hear a faint clack once in a while on a large retraction, but most of the time it runs really smooth, no problems at all. I really like it. So we're ready to start our testing, but one of the main reasons why you might want one of these super constrained filament path extruders like the Hemera or the Microswiss NG is so you can print flexible filament successfully. If you've ever tried to print flex on a Bowden machine, it can be pretty challenging, even on some direct drives. It can hop over the extruder, bulge out the side, and never get forced through the hot end. So that should solve some of those issues. And that is also my main focus in testing. I've done a lot of flexible filament tests in the past, but this one should be the best candidate so far to print it successfully. So let's see what happens. Let's take it to the time lapse. First up, a benchy and PLA. If you can't do that, you might as well go home. It turned out just fine. We've got a little bit of stringing here and there, but again, I haven't tuned this at all. I just threw it on, did some rough slicer settings, and this is what we get. For an Ender 3, the quality looks good. Very little vertical artifact. Everything is as it should be. But that's the easy one. Then we move to PETG. Now, this one is a little bit stringier than I'd like it to be, but that's probably the quality of the filament. It is starting to get humid around here, so that might be the filament's fault. But again, for an Ender 3, not tuned in, for PETG, very respectable print. No problems. And then we move to some of the flexible prints. Now, I'm a little confused on some of these. This is Filamentum Filaflex 98A short hardness. The filament quality is probably really bad. It's stringy. I actually have some gaps in the extrusion. I don't know what happened to this filament. The extruder printed it just fine. It wasn't its fault. This isn't very flexible filament, so it should have done a lot better than that. But again, I don't know what happened, but I ran the test anyway. So let's move on. Then we go to NinjaFlex. Now, there were some definite retraction issues here you can see in the wheelhouse. Again, we might be suffering from just a bit of moisture here. It completed it just fine, but the overhang didn't do as well as I thought it would. NinjaFlex has a lot of flex to it, a very flexible filament, but not the most flexible. This one is X60. If you saw my Hemera video, I printed one of these out. It didn't look anywhere near this good. Remember, this is a 60A shore hardness. You can just roll this stuff up. It is super flexible, and it came out so well. I cannot believe how it did on that really flexible filament. That stuff is the consistency of rubber bands. So this is probably the most flexible, best benchy I have ever done. So nice job, NG. So there it is, the Micro Swiss NG, and after the upgrade and all the tests that I did, I really like this extruder hot end combo. Even at the $120 US, I think it's well worth the money, just because of all the things it does upgrade, and all of the different filaments it's going to enable you to print. Nicely done on this one, Micro Swiss. I think this is probably one of the best all-in-one upgrades for an Ender 3 that I've seen on the market yet. Now, of course, Micro Swiss did not pay me to make this video. I paid for this with my own funds, and all opinions expressed are my own. That is it for today. I hope you found this helpful, and I'll see you really soon on the next one.